that involves an absolute value sign, because it's a little bit more difficult. It's not terrible. It makes sense. Um, but I wanted to do one so you didn't have to think through this on your own if you run into it. So here is example 7. So we're going to do the definite integral from -3 to 7 of the absolute value of x minus 1 dx. And if we think back to the beginning of the semester when we were learning about derivatives, anytime we saw an absolute value, we would be like, okay, hold up, it's not an absolute value graph, it's actually what? Piecewise. And we would take this and we would rewrite it. So I'd go over here and I'd say, okay, this is actually a piecewise function, and how would I rewrite it? Yeah, so positive version, negative version, okay? And then the positive version is if x is greater than 1, and this is if x is less than 1, one of them has to be equal, doesn't matter. Okay, so what we're going to do is we're going to say, okay, to apply this to a situation where we're finding the area under the curve, then we're going to break up this interval to the left side of 1 and the right side of 1. So we're going to have one interval that's from -3 to 1, and then the other interval is going to be from 1 to 7. Does that make sense? Okay. So I'm going to say for the interval from -3 to 1, what's the function that I'm working with? -x plus 1 dx, okay? And then the other interval is from 1 to 7, and what's the function that I'm working with there? The positive version, x minus 1 dx, okay? Are you guys comfortable with that? Make sense? Okay, so let's go ahead and do our antiderivatives for each of the pieces. So -x plus 1 would be okay. Michaela, you still doing that in your head? I cannot. I just cannot. I just have to show my work. Okay. Do we need the plus c? No. Because anytime you evaluate a definite integral, you don't need the plus c. It makes sense if you think about it, because if you had like a +5 on the end, for the first number you plug in, you'd have a +5, and then for the second number you would plug in, you'd have a -+5. So you'd just have the positive version, and then you distribute your negative, and then you'd subtract it off. So if you had the plus c, it'd be there, and then you'd subtract it from itself, and then it'd be gone. So you can put the plus c if you want. You're just going to subtract it away every time. Yeah. Okay, let's do the other one. What do we get? And then does somebody want me to do the plus c so we can just see what happens to it? Okay. It's not a bad idea. So then we just know. We just know why they don't write it. 1 to 7. It took me a long time. I just always, okay, you just don't write the plus c. I just memorized it. And then one time I actually thought about it and I was like, oh, it makes sense. That's why they don't do it, because you just don't need it. All right, so let's go ahead and do this one. So how do I do the evaluating? Which one do I plug in first? Yeah, so it's the bigger number. So I plug in the bigger number first. Okay, so I'm gonna put like big, since I'm adding these two numbers together, right? Because it's the whole thing. It's this plus this. I'm adding them together. So I'm gonna do like a big bracket. Okay, so I've got negative 1/2 1 squared plus 1. So there's my first number. Minus negative 1/2 negative 3 squared plus negative 3. There's my second number. We comfortable with that? So I've got bigger minus smaller. First number minus second number.
Why is the second one half?
Say that again?
Why is the second one? Oh my god. Never mind.
I'm good? Can you see how much room for error there is here? We gotta be real careful. So this is not, oh, I'm trying to save paper. We do not save paper on these. We take up space. If we have to erase, we do not smudge. We just put an X through it, move on to clean paper, okay? Because smudginess is gonna help us miss negatives and things like that. Yeah, and it is this is why I said get a whole pen of an eraser, because the little eraser is not gonna last very long. You know what I'm saying? All right, plus. Okay. All right, then what are we doing over here? What number do we plug in first over here? 7. Okay, so 1/2 7 squared minus 7 plus c minus 1/2 1 minus 1 plus c. Okay. All right. We're calculator inactive. This is calculus. They go, "You're fine with fractions, aren't you?" And you go, "Yeah, I guess. I guess I'm fine with fractions. Thank goodness it's only halves." Okay. I'll make it zoom in.
No,
Zoom out.
over, yeah,
Oh, over here. So I don't feel like getting a common denominator. I see there's some fractions over here, so maybe if I put my fractions together, I'll get some whole numbers. The first time I did it, I did get common denominators. I will say that, but I'm not going to do that this time. I'm just going to see how the problem works out differently. So I'm going to go ahead and distribute. Yeah, you can kind of do whatever you want. As long, because at this point that's the thing about calculus, is at this point we're pretty strong mathematically. So as long as you're making legal math moves, you can kind of do things in whatever order you want. This is not the teacher tells you exactly what to do, you do it exactly the same. This is as long as you're making moves that are okay, then you are good to go. So me distributing this now is actually going to take care of our question about the C's. What do you see is happening with these C's over here? The c's cancel. And that would happen every single time. So that's why you can put the plus c in the problem, but you don't need to, because you're always going to get a plus c and a minus c. They're always going to cancel out. And so people have just said, oh, with definite integrals, we just don't put the plus c. It's not that with definite integrals, the c is not there. It is. It's just that every single time you would plug the number in, the c would disappear. So that's why they don't worry about it. We were just seeing what would happen. Yeah, we were just showing that's how it worked. Because if I did it on this side, the same thing would have happened over here. So. Okay, so I've got negative 1/2 and 9/2. That makes 8/2, which is 4. And so I've got 4 plus 4, so I've got 8 over here. You guys agree with that? Okay, and then I've got 49/2 minus 1, so that's 48/2. So it's 24. So I've got 24 minus 6 over here. Would you agree with that? Forty-eight halves minus 6. 24 minus 6. Okay, so we have 8 plus 18. 26? Okay. Anyone remember how to type this in? We've done it on one assignment so far. Not very much. Math. What was it? 9. Math 9. So we're going to go from -3 up to 7. How do we get the absolute value in there? It's still math. Go over to number, and it's the first one, ABS. Okay, x minus 1 dx is at 26. Aha! There we go. It's calculator struggle bus. So if we tried to round it to the nearest tenth, we'd get 26.0. If we tried to round it to the nearest hundredth, we'd get 26.00. If we tried to round it to the nearest thousandth, we'd get 26.000. So, I mean, we got it. The calculator's just struggling a little bit.
What is the name of this line? Like, why is it?
It's the function integral. Yeah. Math 8. If you hit Math 8, that's how you do the derivative on your calculator, derivative evaluated at a number. So we haven't used our calculators to do much evaluating, but that's how you do it. Math 8, Math 9 are the ones that you use during calculator active. Okay, so let's go ahead and get started on the practice assignment.